Hi everyone, welcome to my channel. Please like and subscribe. In this video, we'll be learning on how to read reinforced concrete slab structural drawings. These structural drawings shows the arrangement of slab and its thickness, also shows the location of columns and the beams, and also used to show the reinforcement details. Now, in order to understand on how to read reinforced concrete substructural drawings, there are four main steps that will make you to master. The first step is to identify the grid lines. Grid lines. This as a grid lines. This grid lines. This one. This is as a grid lines. Grid lines passes at the center of each columns. Passes at the center of each columns, and these grid lines, they are shown horizontally and vertically. Vertically, they are shown, this is a vertical grid line in vertical. They are shown in numbers from number 1, number 2, number 3, number 4, 5, 6, up to 11. And horizontally, they are shown in letters from letter A, letter B, letter C, letter D, letter E, letter F, up to letter H. These grid lines, they are used for locating beams and columns, and also they are used for setting out construction works. For instance, this is column is located at grid 5G. At grid 5G. Also, this is another column which is located at grid 6G. Also, this is another column which is located at grid 6F. Also, this is another column which is located at grid 8G, and this is another column which is located at grid 8F. All of these columns are located in that ways. Another step is to identify the beam. This double thick lines used to represent the beam. So this are the beams, beams which are represented by these double lines. So this is as the beams. These beams used to support the slab. Used to support the slab. For instance, this is a slab. This is a slab which is supported by these beams. And used to transfer loads. Used to transfer load to the columns because this is a beam. So used to transfer loads to these columns, and to these columns. In this way, used to transfer loads to these columns. Another step is to identify the slab panels and its thickness. The slab panels as area between the beams. So because this is as a beams, so the area between these beams, is known as slab panels. So for this beams is slab panels is this one. So this is slab panel, this is slab panel, another panel, another slab panel, another slab panel, another slab panel, another slab panel. So the area between the beams is known as a slab panels. Inside each slab shows these notes, which is 150 millimeter thick slab. This means that the thickness for this slab is 150 millimeter. The thickness of each slab on all panels is 150 millimeter. Another step is to identify the reinforcement details. In slab, reinforcements are the layers, main reinforcements, and distribution reinforcements. Now, how can we identify the main reinforcements and the distribution reinforcements? Main reinforcements are placed in shorter span direction, and distribution reinforcements are placed in longer span so as to prevent or to control cracking and to distribute loads. And the main reinforcements are placed in shorter span so as to resist bending moment of the main to resist bending moment. Now, for instance, this is a slab panel. This is a slab panel which starts from this grid line, from this grid B to grid C, and horizontally from grid C to grid from grid 1 to grid C to grid 3 to grid 3. So this is a slab. This is the panel of this slab, which have a span in horizontal, in vertical and horizontal. So as we see, in vertical, the span of this slab panel is 51 is 41 50 millimeter, and horizontally the span of this sub panel is 50 millimeter. So you may see here this is shorter span than this one. So this is shorter span than this one. So the main reinforcement should be placed vertically in this way. This main reinforcement should be placed in this way. So its details for the main reinforcement shows that there should be 27 bars with a diameter of 12 at bar mark number 1, with a spacing of 200 millimeter, both bottom and top. This is B1 and T1. Shows that B1 and T1 as a bottom and top for the main reinforcement. So its detail is 21, is 27 with a diameter of 12 at bar mark number 1 with a spacing of 12 millimeter, 12 with a spacing of 200 millimeter, both B1 and T1. This means that this 27 shows that the number of bars required at this slab panel is, and this 12 is the diameter of bars. Diameter of bars at bar mark number 1. This is 01 is bar mark. Is bar mark. This bar mark is used to show where the reinforcement starts and ends from. And 200, this is the spacing of steel bar. Spacing of steel bar. So each steel bar, this 27 steel bar, should be spaced at a distance of 200 millimeter. Now let's see the distribution reinforcement, because as we see, this is distribution main reinforcement, so should be LX. And because this is for horizontal, it shows that it is longer span than vertical span. So this is LY. Because it is longer because the distribution reinforcements are placed in longer span. So means that the distribution reinforcements should be placed horizontally in this way. Should be placed in this way. So the distribution reinforcement should be placed horizontally. And its detail for the distribution reinforcement shows that there should be 21 bars with a diameter of 12 at bar mark number 3 with a spacing of 200 millimeter. B2 and 2. B2 and 2 shows that this is means that at the bottom and the top for the distribution reinforcement. So this is was for the main reinforcement. And let's see, here is distribution reinforcement. Distribution reinforcement for this slab panel reinforcement. Now, its detail shows there should be 21 bars with diameter of 12 at bar mark number 3 with a spacing of 200 millimeter. B2 and T2. B2, this is 21 number of bars required at this sub panel, and this is 12. This is diameter of steel bars. Diameter of steel bars. Diameter of steel bars. And 03 is bar mark. Bar mark. This is bar mark. And 200 is the spacing of each steel bar. Spacing of each steel bar. From one steel bar to another steel bar. So B2 and T2. This is means that at the bottom and top, for the distribution reinforcement. B1 and T1 are the bottom and top for the distribution reinforcement. So this is how the reinforcement detail for the slab is should be leading. Now, also in this structural drawing, you will see where the staircase is located. From this structural drawing, the staircase is located at this area. So this staircase is used to indicate the opening of the slab. So from this structural drawing, the slab is opening at this area, and this stair used to connect floors means that used to connect from one floor to another floor. Also, from the reinforcement details, how can you determine this is as a type of slab? Because as we said, for the distribution reinforcement used to transfer loads, and you're supposed to know which kind of this slab. The kind of slab is there is one-way slab and two-way slab. So if the ratio of LX, which is shorter span, over longer span, which is LY, is less than 2. This means that is two-way slab. And if is greater than or equal to 2, this means that it is one-way slab. Now let's check here. LX over LY. LX which is 4150 over 5350. When you divide this one, it will be equal to 0.78. This means that this is less than 2. LX over LY is 0.78. This is less than 2. This means that it is two-way slab. So if it is two-way slab and this distribution reinforcement, which is placed in horizontally, for the long span, used to distribute loads. So the loads for the two-way slab are distributed in both directions, horizontally and vertically. This is the best way on how to lead structural drawing for the slab. Thank you for watching this video. Please like and subscribe so as to be notified for the next video. See you.